Hi there, my name is Conrad and this is part 2 of my Introduction to Using Expressions in Nuke series. If you haven't already watched part 1, I suggest you go back and watch that first and then come back to this video later. In the previous video, we already looked at how to reference data from different knobs or nodes in our Nuke script. In this video, we're going to take it one step further to look at how we can reference data from different frames in our script, not just the current frame that we are viewing or rendering. Then we are going to take some of the knowledge that we learn about referencing frames and use that to help us create procedurally generated animation that doesn't need us to set any keyframes. Then we will look at using if statements and combine that with the $GUI variable to improve the interactive performance of our scripts and change the settings of nodes based on predefined conditions. And finally, we will combine expressions with the text node to display what is happening in our script, which will help us keep track of our project. So let's get into it. Until now, all of our expressions have been referencing data from the same point in time that we are currently evaluating the expression. In this example, I've set an animation in Transform 1, with the X translation set to 0 on frame 1 and 50 on frame 100. The X translate value in Transform 2 is linked up to Transform 1 with the basic expression transform1.translate, and you can see that as we move through the frames, the two nodes match. We can see the values of each node over time in the curve editor. The curve editor is a great tool for visualizing what an expression is doing, especially as the expressions get more complicated. It shows us the value of any knobs selected down the side here of any nodes open in the Properties pane. We can modify the expression in Transform 2 so that we get the value of Transform 1 at different points in time. We do this by adding a frame number in brackets after the link to the knob. This tells Nuke to get the value of that knob on that specific frame. Let's add 50 in brackets to the end of this expression. Now you can see that the value of X in Transform 2 is constant and always matches whatever the value of X is at frame 50 in Transform 1. If we move the keyframes for Transform 1 on the curve editor, you can see that the value for Transform 2 updates to match the new value. What if we want Transform 2 to have the same animation as Transform 1, but just with a 10 frame delay? To do that, we need to introduce the frame variable. The word frame is a predefined variable in the Nuke expression language that always returns the value of the current frame. If we created a new transform node and just entered the word frame as an expression for the X translate, you can see that on every frame our value matches the frame number. This is handy in itself and can allow us to create animations without setting any keyframes, but we'll come back to that later. Let's go back to the expression in Transform 2. Now we can replace the frame number that we entered in brackets with the word frame. Now the point in time that we are referencing Transform 1 from changes on every frame, but we're back to where we started, matching the value of Transform 1 exactly. We want a 10 frame delay, so we need to get the value of Transform 1 from 10 frames earlier. Let's add -10 after the word frame inside the brackets. Now you can see that Transform 2 has the same value that Transform 1 had 10 frames ago. So we have the same animation but with a 10 frame offset. It's important to note that the -10 went inside the brackets. If we put the -10 outside the brackets instead, we wouldn't be changing the frame number. We would be looking at the value of Transform 1 on the current frame and then subtracting 10 from that value. You have to think about the order of operations in your expression in the same way that you'd think about the order of operations in a maths equation. So we can see that the frame variable will return a different sequential number on every frame. This can be really useful to create procedural animations that don't need us to set any keyframes at all. We saw a really simple example when we created an expression with just the word frame. This returns a value that is just the frame number. In the case of a translate, we have a constant movement. We can use simple maths like addition or multiplication to modify this animation. For example, we could set the expression to frame times 2 to make the animation twice as fast, divide it by 2 to slow it down by half, or we could multiply it by -1 to invert it. But I probably use the frame variable the most with the noise node. By default, the noise node generates static noise. The best way to add natural movement to the noise is to animate the Z slider. To set this up manually, I would go to the first frame, set a keyframe, then go to the last frame and set another keyframe and change the value. Then I would preview my noise and change the value on the last keyframe if I want it faster or slower. But now we don't need to create any keyframes. We can just add frame to the expression for Z. If we want to speed the animation up, we can multiply the frame number by a number greater than 1. If we want to slow the animation down, we can divide the frame number by a number greater than 1, or multiply it by a number between 0 and 1. Dividing it by 10 will make it 10% of the original speed. We can also use the frame variable with other built-in functions to quickly create complex animations. The random function, for example, generates a random number between 0 and 1. We can add the frame variable as a seed for the random number generation to change the results of the function. And then we can modify the frame variable to adjust them further. We could divide the frame by 2 to reduce the frequency of the noise pattern by half. We can then multiply the result of the random function by 10 to increase the range from 0 to 1 to 0 to 10. Again, notice the order of operations. The division inside the brackets applies only to the frame number, so this affects the frequency. The multiplication outside the brackets affects the result of the random function after we've changed the frequency. Another set of examples are the sine and cosine functions. If you remember trigonometry from school, you'll remember that the cosine or sine function produces a value between 1 and -1 based on whatever number you give it. If you enter the frame variable into the functions, they will produce a smooth wave animation, which we can use as the basis for all kinds of more complex motion. And we can perform the same kinds of operations to the frame variable to alter the results of the function. Again, dividing the frame number by 2 will double the wavelength of the result. Dividing it by 3 will triple it. Let's combine a couple of these functions to create an animation for this white circle. First of all, let's add cos brackets frame divided by 10 to the x translation knob. Now we have a small, slow back and forth motion. Let's multiply this by 100 to make it more obvious. Let's copy and paste this expression from the x into the y translate. Now we have a diagonal animation. The cosine and the sine functions are similar to each other but are offset, where one gives us 1, the other gives us 0. If we change the cos in the y expression to sine, we now have a perfect circular animation with no keyframes. Let's add some random noise to the expression. Let's wrap the existing expression in brackets, and then afterwards add plus, random, and then the word frame in brackets, and then let's times that by 10 and place all of this new section in its own set of brackets. Now we have a small wobble animation added on top of our circular motion. So you can see how we can combine several simple expressions to quickly create complex animations. One of the simplest and most useful expressions is simply $GUI. $GUI is a variable that detects whether you are using Nuke via the graphical interface or not, and returns a value of 1, true if you are, and 0, false if you aren't. If you are working on your script in Nuke, then you're obviously using the interface. But if you have sent your script to the render farm, it's running your script without the interface. Rendering your script locally, using the default render settings, uses the interface, but submitting the renders to the built-in background render feature does not. Here's a setup to demonstrate. I have two text nodes. One says using GUI and the other says not using GUI. I've connected them to a switch node with not using GUI connected to the 0 input and using GUI connected to the 1 input. In the which knob of the switch node, I have entered $GUI as an expression. Now, at the moment, we're using the Nuke graphical interface, so the $GUI variable returns 1 and we see the text that says using GUI. If we render this script with the regular local render and open the result, you can see that we get the same thing. But if we hit render and check the render using frame server option, this will render the script using the background render feature, which will render the script without the interface. When we reload the frame that we just re-rendered, we can see that the text says not using GUI, which proves that this switch was set to 0 while the script ran in the background. This is the same result as we would get if we'd sent the script to a farm. While you're working on your composite, you want the script to be as responsive as possible. But if you are working with computationally heavy nodes, your script can get really slow. You can use $GUI to automatically turn off slow nodes or reduce quality settings while you work to speed Nuke up, and then switch nodes back on and restore higher quality settings when you render. The easiest way to do this is to add the $GUI expression to the disable knob in any node. In this script, I have a defocus node blurring this checkerboard. If I right-click on the disable knob and choose Add Expression, I can add the expression $GUI. Because we're using the interface, $GUI will return 1, or true, which means the node will be disabled. Now, when we look at the node, we can see a single diagonal line across it. This shows that the node has been disabled with an expression, as opposed to the cross that we usually see when we disable a node manually. And we can see that the node isn't blurring the checkerboard anymore. But if we render this using the background renderer and check the resulting image, we can see that the checkerboard has been blurred. This is because when we render in the background, the $GUI expression in the disable knob will return 0 instead of 1, and the node won't be disabled. This is a useful trick if you have set up a heavy node and you know that it's working the way you want it to be, but you don't want Nuke to have to calculate it continuously while you work. We can make this expression slightly more complex and use a conditional statement to change settings rather than just turn a node on or off. In programming, we can use if statements to check if certain conditions are true or false, and then perform different operations depending on the answer. The if statement is made of a condition and then 2 options, and follows the logic: if the condition is true, do option 1, else if the condition is not true, do option 2. In this example, we're going to use an if statement to reduce the amount of motion blur samples in the scanline render node while we're working with the script, then increase the samples when we send the script to the render farm. This way, we will still see rough but fast rendering motion blur while we work, but we will get the full quality in the final image. I have a 3D scene with an animated cube. I've set keyframes on frame 1 and frame 3, and I'm viewing frame 2. Currently, there is no motion blur. Let's go to the Multi-Sample tab and adjust the number of samples. With the samples set to 1, we don't get any motion blur at all. When we increase the samples to 2, we see 2 instances of the cube. These 2 positions represent where the cube is at different points in its motion between frame 1 and frame 3, depending on how we've set up the shutter settings. As we increase the number of samples, we can see that we add more and more instances of the cube in between. This creates a smoother appearance of continuous motion blur. But to create this effect, Nuke has to render the 3D scene as many times as there are samples. In this case, we need to increase the settings up to 100 before the steps in the motion blur start to get close enough to appear as continuous smooth movement. We don't want to have to render this scene 100 times whenever we change frames while we're working in our script. This will be painfully slow. Let's add an expression to our samples knob. We'll start by entering $GUI, which we know returns true or false. Now, after that, we add a question mark. This ends the conditional part of our if statement, so now we're asking, is $GUI true? If it is true, we want to reduce the motion blur samples to 5. This way, we still see the motion blur. It will look rough, but it's good enough to work with, and it'll be faster to preview. So let's add a 5 after the question mark. As it stands, this expression is saying, if we're using the interface, set the samples to 5. But we haven't defined what we want the expression to do if $GUI isn't true yet. That's the else part of the if statement. If $GUI is false, we must be rendering our script on the farm, in which case we need to set our motion blur quality to the full 100 samples. We separate our else from our if statement with a colon, so let's add :100. Now our expression reads, if $GUI returns true, set the samples to 5, else set the samples to 100. If we look at the result in the viewer in Nuke, we can see the low quality motion blur. But if we render the scene with the background renderer, we can see it renders beautifully smooth motion blur. We can combine the frame variable and the if statements that we've just learnt about to change a switch node based on which frame number we are viewing in our timeline. Let's imagine we want to switch between this checkerboard and this color wheel on frame 50. We could go to frame 49 and set a keyframe to 0, then go to frame 50 and set a keyframe to 1. Or we can use an expression. The switch node expects a 0 or a 1, and a conditional statement returns either a 0 if the condition isn't true or a 1 if it is true. So in this case, we could add an expression that says frame greater than 49. We don't need to add anything else. If the frame number that we are on is any frame before frame 50, the frame number isn't greater than 49, so the expression returns a 0. As soon as we get to frame 50, suddenly the frame number is greater than 49, so the result becomes 1, and the switch flips. Alternatively, we could set the condition to an equals. If we enter the expression frame equals 50, we need two equal signs, the condition will return true only when we are on frame 50. And we could set the switch to be 1 between two frames by introducing the AND operator. Let's say we want the color wheel between frames 40 and 50. We want to check if the frame number is greater than 39 and less than 51. So we could add 39 less than frame, and then we add two ampersands to denote and then we add our second condition, frame less than 51. Now our condition is only true if our frame number is greater than 39 and less than 51 at the same time. So the switch shows the color wheel from frame 40 to frame 50. On its own, this might seem an overly complicated way to animate a switch node, but it's a good example of how conditional statements can work. We can also build on this to make a more procedural script or template. We could, for example, find the frame range of a read node connected to the switch node and base our condition on that, but that's for another video. My final tip for this video uses expressions to create dynamic text in the text node or in node labels. I use this mostly to burn in frame numbers into an image for reference. Let's start with the text node. In the message field, we can type the text that we want to display. If we type frame, you can see that we just get the word frame. But if we open square brackets and type value frame and then close the brackets, we're telling the node to look up the value of the frame variable and display the result. You can see that the number dynamically changes as we move through the sequence. If we wanted to modify the frame number before we displayed it, we have to change the word value to expression. But now we can halve the frame number with frame divided by 2. Now the text node will evaluate frame divided by 2 and then display the result as text. We can add a regular string of text outside these brackets to create a complete sentence that dynamically changes. Let's add, the current frame number divided by 2 is, and you can see that we have a sentence that updates automatically. This doesn't just work for frame numbers. We can look up any knob value from any node in the script. We could display the brightness increase being applied to an image from this grade node with value grade1.multiply. Now the text node will automatically display the multiply value being applied to the image. This is useful if you are asked to render multiple versions of something to show your supervisor. They can see which value they are looking at in any of your renders. We can add a similar expression to the label knob of the node. Let's go to the label of the grade node in the Node tab and enter multiply equals and then in square brackets value multiply. Remember that we don't need the node name if we are referencing a knob in the same node that we are adding the expression to. Now we have a label that will dynamically update when we change the value of the multiply slider. This makes our script much easier to follow. So as you can see, even simple expressions in Nuke can be really powerful. Setting up expressions can allow you to work more efficiently and more procedurally. Working procedurally will not only allow you to work faster, but it will allow you to build far more complex effects, allow you to change things in your setup much more easily, enable you to replicate your effects more easily for multiple shots, and help you reduce the chance of introducing user error into your setup. Once you start working with expressions, you'll find more and more uses for them. I'm constantly learning new tricks and techniques. As with any kind of coding or scripting, if you get stuck, don't be scared of reading the documentation or searching the internet for answers. The Nuke documentation is a good place to start for good descriptions of all the built-in functions. And for some more inspiration of things you can do with TCL in Nuke, check out Attila Gasparetz's blog, where he has collated loads of snippets of code for all kinds of situations. I've linked to his site in the description below. If you're new to expressions in Nuke, I hope this video has shown you that expressions aren't as complicated as you might have thought, and has given you the confidence to start exploring the possibilities yourself. And if you've used expressions before, I hope there were a few little tips in here for you. I know I've learnt a few things while I've been creating this video. If you have any comments about any of the expressions that I've mentioned, feel free to ask them in the comments below. And please share the expressions that you use in your everyday work in the comments as well. If you enjoyed the video, please hit like and share this video with other artists who might find this useful, and subscribe to my channel to make sure you don't miss future tips. I will definitely have more videos using expressions coming soon. Thanks for watching.